Oh, I'd like to welcome everyone to another Drink Time with Robotics. I'm your hostess, Deborah with the Mostess. Tonight I will be interviewing Rob Rujarowny, a teacher at Rogers Middle School in Long Beach Unified. Rob has been teaching technology electives for 10 years. Cheers, and thank you for joining me.
Cheers.
Cheers. Since Rob is experienced in teaching with robots, robotics, and artificial intelligence, we will be talking about how they are used today and how we would like to use them in the future in education. So, Rob, I'd like to start off with a question. When you teach with robots in the class, what is the expectation of their use in technology today?
Well, when I'm using them right now, there's a couple of different instances where they can be used. In the classroom, they're kind of used for hands-on experiential learning of kind of the design process, where kids are having to a task is given to them that the robot needs to accomplish. They're tasked with either individually in pairs or in a group, and typically in a group setting. They're going to come up with a design for a robot to go ahead and accomplish that task. They're going to then build it. They're going to code it in many cases, and that has transformed in the last few years from having to have a rudimentary knowledge of a coding language and then having to code in that language to now being able to code using block-based coding, which is a big jump forward for that, but that's kind of a little bird walk. They design it, they then test the bot in some sort of an environment that is controlled for them to be able to go ahead and perform the task, and then they'll go back and iterate either the design, the build, some of the strategy on accomplishing the task in order to go ahead and make it work. And all of this is designed with in keeping in mind of what the task of today's engineers and today's technologists need to accomplish in both college and career fields. So it's kind of a backwards map or a backwards reverse engineer of the skills, some of the softer skills, and some of the learning experiences that we want kids to have in the classroom, or in my case, in the club classroom or the club lab situation. And then in order for them to be successful later down the line, if they choose to go into science, technology, engineering, mathematics fields.
So, with those tasks, are they being asked to like move a ball from point A to point B in that kind of aspect?
And it depends. So the type of robotics that we teach at our school is called VEX EDR robotics.
Mm-hmm.
And the VEX program, they provide pre-made metal pieces and plastic parts and gearings and wheels, all the different parts of things that kids are going to need for different systems involved with creating a robot. And then they can also on their own fabricate their own parts and pieces as well, as long as they conform to a certain set of guidelines. And it's a pretty extensive set of guidelines that VEX uses. Now what VEX does is they'll provide you with activities for the classroom. So for example, there's a way to create a robot that has a lift mechanism, kind of a grabbing and a lift mechanism designed to pick up a foam ball and deposit it into some sort of a container.
Okay.
But then annually, they also develop a game in which they actually host competitions worldwide, and that game changes every year. So for example, the last couple of years, that game has been to collect cubes, kind of open cubes, and stack them or place them on tall pipes or other types of objects in a game field within a 2-minute period. And those games are designed for them to not only do the design process, but then to also work with another team who they don't know.
Yeah.
And those two bots competing against two other bots. So a grand total of 4 robots competing as 2 teams against one another in a tournament competition.
So the robots are used for in class to manipulate, to do some kind of manipulation and then use for competition outside.
Right. The in-class portion would be really teaching the mechanics and the different systems involved in creating a robot, as well as the technology involved in how to code it. Um, it's much less about strategizing for a game, whereas the competition, there's more of an assumption that the students have had some sort of an experience building the robots, working in that type of a design process before in some capacity, and their focus is now more so on competing and strategizing in gameplay.
Okay. Now, let's take robots and building robots and robotics, and
Mhm.
let's project into the future
Okay.
20 years from now. What would you like to see if both of you and I are still teaching at that time?
Oh God, I hope not.
Don't go there. What would you like to see robots and robotics being done with the classroom and in education?
Well, I would say that for the most part right now, both at the high school and the middle school level, robotics is kind of associated only with STEM. It doesn't really have I mean, there are competitions, but again, they're very narrow in scope with only kind of working towards a certain, um, I don't want to say a certain group of students or certain type of students, but they're not really broaching um, the same type of status, say, that esports has suddenly come on and begun to do. Whereas esports has taken something that most students are very familiar with in terms of gaming, and they're now building curricula and different types of advancements with how they can use that to develop students' interests in lots of capacities within the gaming. Um, I use the word arena, but basically within the gaming structure. Robotics hasn't quite done that yet. It's still very, I mean, there's lots of competitions, but typically those competitions are associated with students who are in STEM-like pathways
Okay.
or who have a penchant for science and technology. And I'd like to really see it in 20 years' time become something as ubiquitous as, say, a high school football team being kind of a given at a school, or a glee club having a robotics club that's open to a lot of different students, not just students who seem to fit this ideal or this mold of pre-engineering, as it were.
Okay. You also have talked to me about teaching AI, artificial intelligence, as a newer part of the field of education. How do you use it in your classroom?
Right now, very rudimentarily. Um, in order for it to get used, again, there's a lot of buildup that has to happen ahead of time. Students have to be familiar with certain types of systems, certain type of computer coding rules and terms such as loops and Boolean theory and things of that nature in order for them to go ahead and be able to be successful when they come into using artificial intelligence for any type of a capacity that we might have, and especially at the middle school level. It's basic. I kind of liken it to, we provide opportunities for the students to kind of earn what the scouts used to actually have a stitch or a sew-on badge to a sash. Now we have digital badging that we kind of do that with, but it's very similar in nature. So for example, the students created an avatar to use in their online portfolios or their online personas that they were
Mhm.
creating for some of the things we do in class. And to do that, they used a component of Google called AutoDraw, which basically as you start to draw shapes, the computer system, based on playing another game called Fast Draw, in which it asks you to draw something such as a penguin or to draw a bow and arrow as quickly as you can within a short amount of time. The Fast Draw game teaches Google's AI computer to start to associate the drawing and the shapes with that object. So
Okay.
what the students created in their avatar wasn't something that they hand drew themselves. It was as they were drawing in the auto draw application, the computer started to sense what they were trying to do. And even if they weren't really good artists, which many of them
Yeah.
weren't, it went ahead and associated what they were trying to create and gave them a range of pre-made images that they could then incorporate and create the overall design.
Okay. Good. Going back kind of to that same question, where would you like to see AI in the future?
Well, it basically in every classroom. Um, that's again, that's going to take a lot of humble pie being served to a lot of educators who still want to be the sage on the stage, versus allowing students to utilize artificial intelligence to do a lot of the tasks that many teachers still want them to be able to do on their own. For example, the auto draw, I can see that in the future possibly kind of overtaking teaching handwriting.
Okay.
I mean, scripting in one regard could be something that would be associated more with motor skills or almost like occupational therapy, for example, whereas AI, very simply, the students could be almost thinking or just kind of doodling or combining of a lot of different kinds of media, and the AI will identify what it is that they're going for, even by theme, probably, and start to help them construct whatever meaning they want in whatever format they want it, whether that be through art or through text or through video or whatever it might be. AI will help start to kind of put those things together. And again, that's going to create, there will be meaning and structure to it, but it won't necessarily be 100% original. And I can see a lot of educators, especially, God forbid, if we are still teaching in 20 years, if we're having issues where we're wanting to see the originality and only what the students are capable of doing, and AI will probably easily be tasked with making it very capable for those students to be able to do that, especially students who have any kind of a physical or developmental issue where they need something to kind of assist them with getting their thoughts out.
Okay. Okay. Along those same lines, with artificial intelligence, is the expert system is the computer system that emulates the decision making ability of a human expert. Known as expert systems are designed to solve complex problems by reasoning through bodies of knowledge represented mainly as if then rules rather than through conventional procedural code. Do you think this is where education is heading? Why or why not?
Maybe higher ed.
Okay.
And if our current paradigm holds up, I would say again, if there are STEM or tech pathways at the high school level, or even that filter down, say, into a kind of a CTE situation at the middle level, maybe. But again, right now it's such a niche that is based on grant-based or non-school-based funding, I guess would be the better term. So if you really want it, I mean, if you're going to advance anything, you're going to have to get it yourself. I just saw a colleague on Twitter posted that they had just got a treadmill that has virtual reality set to it. So if you've seen the movie or are familiar with Ready Player One, it's a very similar type of gaming setup, physical gaming structure that's designed to allow students to create content that immerses someone with VR goggles and this treadmill into some sort of a pretty authentic digital environment. And they're going to start working with that in their classroom in a single capacity. But again, that's a niche school that is a STEM school taught by someone who had experience in the field first and has come back into education second and is now teaching kids who have demonstrated an interest or met whatever criteria that they've established in order to be successful in that path. So it'd be nice to see that. I'm not a fan of this, determine your life when you're 13 years old kind of mentality that we seem to have sometimes based on your interests. It's like, no, there needs to be a lot of different experiences in secondary school, especially, I think, and maybe even in higher education for students to be able to determine how they want to utilize that type of technology for all kinds of purposes.
Okay. Yeah, I agree. I think, even now in elementary, we're asking kids to decide what they want to be.
Mhm.
Are they meeting certain criterias? We're asking first and kindergartners and first graders, how are they showing perseverance and um, initiative and perseverance as a kindergartner and first grader? Now, to
Mhm.
me, that's a joke, but you know,
No,
because
it's very similar. We're asking, eighth graders. They just took the PSAT in October.
yeah,
They'll get the results just after they apply to the high school programs, the 40 or more high school programs available in the district,
yeah,
and then they'll get the results after they've been accepted.
yeah,
So there's things that are being done, and that might be very indicative too of how things are in this tech world, where you kind of have these great notions, but the implementation of them is either financially constrained or um, it's seen as only for a certain group of kids or a small number of kids.
I agree with that. I think that some of these things, like VR goggles, you're seeing ads for them now. So they're coming down to some reality kind of price, but they're still like, the price is way out there.
Oh yeah.
And to ask parents for donations for them or PTAs for donations, and you can't have just one in a class.
No.
You need to have multiples because everybody wants to be on the VRs. Because I see the benefits of them. When I was researching these questions, I came across an article that talks about 10 ways that virtual reality is already being used in education. They're being used for virtual field trips,
Yep.
language immersion, skills training, philosophical theories, architectural and designs, special education, distance learning, improved collaboration, game based learning, and virtual campus visits. I mean, not everybody can afford that, which I think makes technology somewhat unrealistic to have in everybody's classroom.
Well, the other thing too is, did we really need a replacement for field trips? I mean, I can see it if you're in a rural situation where you can't get to a museum and you'd like to, or if you're interested in a remote college that it's going to be very difficult and challenging to travel to if you wanted to, then these things can come up. But again, it doesn't seem to be sold in that regard. It seems to be sold as well, let's just replace those things
Yeah.
with, virtual reality or artificial reality and whatever case you have. And, the same thing, if you go back to robotics, I would estimate in the 10 years we've been doing robotics at my school, we've probably spent $10,000 or more on equipment just in order to have maybe a dozen students per year participate in the program.
Wow.
And then in my classroom, again, 30 kids can maybe assemble two, maybe three robots at a time, have to code them using three different machines to code them
Wow.
at a time, and then disassemble them, recycle the parts that they were using, and then make the next group get a turn to go ahead and use them. So same thing. You're going to have to either be someone who's very familiar with grant writing or using other financial means to go ahead and sustain once you jump in. It's kind of, I'd say that's probably the case with any tech too, is once you get going, you better have deep pockets because you're going to need them in order to keep up with whatever's the next phase or the next iteration might be.
Yeah. Well, Rob, I want to thank you for coming tonight. Cheers.
Cheers to you. Salute.
Salute.
Ah.
And until next time, this was Drink Time with Robotics. And this is Deborah Palmer signing off.